What's up, everyone, and welcome to episode 7 of Drew's Sorta No Science. I'm Drew, and thank you for listening. If you're watching this on YouTube, you can see that I'm wearing a hat as well as some sunglasses. I have a awkward sunburn on my forehead from wearing a headband the other day outside, so I decided to throw on the hat and the sunglasses because it's summer now. So, time to celebrate. But today we're going to talk a little bit about technology and physics and some biology and talk about our next physics topic, which is just physics in general. So, let's get into it. This first thing I'm going to talk about today is from Physics Today. Bug-sized aircraft flies by light. The low mass and high thermal conductivity of this device enable it to levitate by forcing heated air through the channels of its cardboard-like structure. Solid-state machines are being used more and more to replace devices with moving parts because they produce less friction and heat, and they require less service because they have less moving parts. And now, John Cortez and Igor Bargatin from the University of Pennsylvania have built a solid-state flying prototype made of micron-thick metamaterial plates, and it's powered by light-driven fluid flow. These plates were made by coating a silicon layer with nanometer-thick alumina, and they have carbon nanotubes. It comes out to be about 60 micrometers thick. Now, so as an LED light warms the bottom of the plate, gas molecules are forced downward by thermal creep, and they did different tests at different atmospheric pressures. So at normal atmospheric pressure, the plate rises about half of a millimeter for about 1 second until the device moves away from the light. And then they also did tests at upper atmospheric pressures, and they found that it rose about 10 millimeters, and it was able to lift something that was about 3 times its mass. All right, next thing we're going to talk about is a little bit of biology. This is from phys.org, and it says, a bizarre new species is discovered on Twitter. Researchers from the University of Copenhagen's Natural History Museum found a new type of parasitic fungus on Twitter. Biologist Anna Sophia saw a picture of a North American millipede on Twitter and saw dots on it that stood out to her. After some digging, she and her colleagues found that the museum had a collection of North American millipedes with the same fungus, but it had never been documented before. So they went through the process and they documented it, and they essentially discovered a new fungus, all being sparked by a picture on Twitter. So I think that's pretty cool. Using social media to make new discoveries in science. All right. So that wraps it up for the different things, new things in science that we're going to talk about this week. So we're going to move on to our next physics topic, which is just, I don't want to kind of take the step back, already talking about classical mechanics and also about modern physics, but I felt that it was necessary because I think I probably should have kind of talked about this in the first place, about what even is physics. So, what is it? Physics is a branch of science and defined as The branch of science concerned with the nature and properties of matter and energy. The subject matter of physics, distinguished from that of chemistry and biology, includes mechanics, heat, light, and other radiation, sound, electricity, magnetism, and the structure of atoms. Now, there are two main branches of physics. That is classical physics and modern physics. Now, I kind of gave the rundown already of modern physics, and we kind of talked a little bit about classical when we talked about classical mechanics. But those two branches together kind of have these sub-branches to them. Those being classical mechanics, thermodynamics, and statistical mechanics, electromagnetism, relativistic mechanics, quantum mechanics, optics, condensed matter, particle and nuclear physics, and cosmology. Now, there's also what they call interdisciplinary fields, which are things such as astrophysics, biophysics, chemical physics, computational physics, environmental, engineering physics, mathematical, medical physics, quantum computing, that type of stuff. So the world of physics is very vast. It is very large, and as time goes on, there will probably be more of these interdisciplinary fields, these different branches of physics, created and or discovered. But that's kind of a overview of physics itself, and like I said, we'll take a deeper dive into some of these topics we already have with classical mechanics, and in the future we'll take a deeper dive into more of them. But that pretty much wraps it up for today. If you liked it, please share, tell some friends. If you haven't listened to episodes 1 through 6 already, I urge you to do so. Everything I talk about in those episodes is still very relevant today. And I think that pretty much wraps it up. We'll see you next week. Peace.